In this video, I want to talk about the parametric equation of a circle. Okay, so you should know the equation of a circle. The general form of an equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Now this is called a Cartesian equation. This is called a Cartesian, I think it was a mathematician, Cartesian equation. Now there's a problem with this equation in the sense you're defining the equation with respect to the center and the radius. Okay. Now, so I'll explain the problem later. So let's work with this equation. So what happens if I say divide the whole thing by r squared? So let me do. So this is also a good revision for your algebra, trig. So I'm going to divide the whole thing by r squared. I'll tell you why. So y minus k the whole squared over r squared is equal to 1. Okay, so what is happening now? So this is same as writing x minus h over r the whole squared plus y minus k over r the whole squared is equal to 1. Okay, now this is a form which can be used for a trig form. Now for the trig in trigonometry, and one of the basic identities is cos squared theta, or let's say cos squared t, plus sine squared t. So let me write theta. Okay, the use theta will explain. So cos squared theta plus sine squared theta is equal to 1. So I see a 1 on the right hand side, and I'm going to, and I also see a squared here, a squared here. So what if I say let cos theta is equal to x minus h over r. Okay, now if you make x the subject, I hope you should be able to understand this directly. If you make x the subject, x is equal to r plus h cos theta. Okay, and if you let sine theta is equal to y minus k over r, and if you make y the subject, this implies y is equal to r plus h cos theta. Now I told you there's a problem with the Cartesian form, in the sense if you want to find so the Cartesian form defines a circle with respect to the center and the radius, whereas a parametric equation defines x and y in terms of theta, and that is useful. Okay, so let me explain that. Suppose if you draw a circle, okay, if you draw any circle, so let me draw a circle somewhere here. Now if you consider this point, I can draw it better. Let me do a better job of drawing a circle. I hope you understand that the problem with this is, if you want to find the x coordinate and the y coordinate, when a particle, suppose this is a particle P, and it is rotating around the circle in an anti-clockwise manner. And if suppose the particle has moved, say, theta degrees, and you want to find the x and the y coordinate, and that's what is useful in many situations. You want to find what's the x and the y coordinate when the particle has moved theta degrees. Because h and r, this should be k. Sorry, I made a mistake here. This should be k. It's good always to check your answer. So r plus k cos theta, and x is r plus h cos. Again, I've done a mistake here. This should be sine theta. Okay, so basically, yeah, h and r, and k are constant. H and k are the center, and r is the radius. So if you know the center and the radius, if you know the coordinate of the center and the radius, you can find the x and the y coordinate for a given theta. So what is changing? So let me repeat it again. So what is changing is x and y changes as theta changes or the angle changes. So you can, in other books, you can also write this, the parameter as t. The same thing can also be written in terms of t. And that's what your calculator would give you. The parametric equation of a circle in your book or in your calculator would be, you can also write like this: h cos t plus r, and y is equal to k sine t plus r. So it's also easy to remember. H is the x coordinate of the circle, and cos, if you remember, is the x coordinate of the circle. So I hope you can relate this. Okay, so how can we do it? I'm going to pause this. I'm going to go back to this question once if you have understood this. Coming back to this question, even if you haven't understood anything I explained previously, let's look at this question. If you know a bit of trigonometry, you can do this. So the question is, write the Cartesian equation of this parametric equation. So let me write it here. X is equal to -1 plus 3 cos t. Okay, the calculator will draw this, but by just entering it, I'll show this on a calculator, or also on Desmos. So if you make it can be write like this. If you make cos t the subject, I hope you can understand this is x plus 1 divided by 3 is equal to cos t. Okay, so I'm making cos t the subject here. And the second equation is y is equal to 5 plus 3 sine t. So if you make sine t the subject, can I write y minus 5 over 3 is equal to sine of t. Sine t. So now I know a trig identity relating cos and sine, which is cos squared t, or yeah, cos squared t plus sine squared t is equal to 1. And this is where you can see the application of trigonometry. So cos t is this. So cos squared t would be, I hope you understand, x plus 1 the whole squared over 9 plus y minus 5 the whole squared over 9 is equal to 1. Now multiplying by 9 to each of them, x plus 1 the whole squared plus y minus 5 the whole squared is equal to 9. So basically this is a Cartesian form. So from this you can say the center. I'll show this on Desmos. Why is this parametric equation useful? So center is -1, 5, and the radius is 3. Okay, now the question is, t is the angle that the particle has moved in a circle. So let me sketch this. Suppose this is a circle with center -1, 5. This is center -1, 5. Now I want to find what is this what is the x and the y coordinate when, say, this is a particle p, and this is a p, this is p0, and this is p1. This particle has moved, say, 30 degrees, and you want to find the x and the y coordinate. So you have to just go the x coordinate by substituting here would be, let me do it here. So the x coordinate would be -1 plus 3 cos 30. Okay, and on Desmos you have to put this in radians, so this will be -1 plus 3 cos 30 pi by 180, or pi by 6. Okay, and y coordinate would be -1 plus 3 sine 30. You can do this also on your calculator, which is -1 plus 3 sine 120, 360, sorry, 30 pi over 180. Okay, so let me show this on Desmos. So the equation that was given, so let's you have to type in like this, bracket, what's the equation? -1 plus 3 sine t. So you have to start with -1 plus 3 cos t, and you have to put a comma, and what was the next equation? Y is 5 plus 3 sine t. So 5 plus 3 sine t. Okay, now here the domain, so you have to change the domain. So it has drawn, if the t is between 0 and 1, that is t is radians, it is between 0 and 1. So if you change the domain, t is the angle, so if it, and t is in radians here. So if you go from 0 to 2 pi is 6.28, so if you go up to 7, it will draw the whole circle. Okay, so this is the circle. So what's the center? The center is, the radius is 3, the center is -1, 5. So this is the center, and the radius is 3. Okay, now the question was, what's the coordinate? What's the x coordinate, x and y coordinate, when the t, or the angle it has moved, is 30 degrees? So this is how you can do it on Desmos. Bracket -1 plus 3 cos, put it in the bracket, 30 pi. If you just type in pi, it'll understand pi slash 180. Okay, and put a comma there. 5 plus 3 sine, again you have to start with a bracket, 30 pi is pi slash 180, and this is this point, exact point. This is this point, so this is the center, -1, 5. Or in other words, when a particle has moved 30 degrees, the coordinate, x coordinate would be -1.598, and the y coordinate is going to be 6.5. Okay, so you can play with this and understand. Say this is this point, so let me do one more. What will be the coordinate when it has moved, say, 75 degrees? So same way, bracket -1 plus 3 cos, bracket 75 degrees, 75 pi slash 180, and then you have to move, you use your arrow key, and then you have to put a comma, 5 plus 3 sine, bracket 75 pi over slash 180. So this is this point, and it does make sense. Okay, so the x coordinate is this, and the y coordinate is this. This exact point when a particle has moved 75 degrees.